Hi everyone. I was briefly introduced. My name is Gauthier Vasseur. I flew from San Francisco, not LA, yesterday. And I came because I was kindly invited by Team Will, my colleague friends over here. And we're working on data strategy that could apply to the world of auto finance. Because you guys sit on a lot of data. And there's probably some ways to squeeze them a little bit more to find, the next breakthroughs that could revolutionize the way you do business. So the purpose of this presentation is to show you how close you could be to get that gold from your data. So it's all about getting keys. Rapid introduction so that some of you don't remember me from 2 years ago. 2 years ago, I had the chance to be here also. That's why I love the conference so much. I came back. I actually come from the world of finance, not auto finance, but corporate finance. I worked in corporate finance, banking for corporations, treasury, accounting. Then I moved to Silicon Valley, where I've been working for 15 years, mostly high tech, Oracle, Google, and a few startups. And then I realized that maybe the world needed to know a bit more about data. I found it so revolutionizing that I said, now it's time to share. So I joined the world of higher ed, and that's what I'm doing here today, is share with you everything I learned and everything I keep on learning with professionals like you. So I'm currently at the University of California, Berkeley. I'm the executive director of a research center for business analytics. So I don't care much for crazy going to Mars type of analytics. All we study, all we research, and we teach is applied analytics, the one that you can use and make things with, like tomorrow, not in 10 years. And because I'm passionate about teaching, I teach at the neighboring university, Stanford. Not as good, but that's okay. And at the Association of Finance Professionals, and also invested in a French teaching company, training company called Le Pont. So that keeps me busy. Also, last but not least, this is not self-promotion because the book is in French, but I just released the book early October. I become a data pioneer, devenez un data pionnier, which summarizes everything that professionals should know when they want to do data. So once again, no rocket science, just the concrete recipes on how to make data work. So I got a lot of slides, and I didn't know how long the session would be. And I'm thankful for, by the way, giving me half an hour, which is wonderful. So don't freak out if I'm going a bit fast on some slides. You're not missing anything. I'm just adjusting. Because I could spend 3 hours with you and have fun. I'm not sure you would have fun, but... Okay, so I would love first to go back to basics. Before we do data, I want to make sure that we understand why we're doing data. And just to tell you that it's probably more important than you think. Because we do data not because it's cool. I know it's kind of trendy. At the next dinner, you say, yeah, data, I'm data-driven, and you drop all these keywords, but that's not the reason why we should be here saying we need to understand data. The reasons are much more profound, and actually, my colleague here, you alluded to some already, and I was really happy to hear that. The first one is the fact that we live in a world that is crazy, but this you know already. This slide is from 10 years ago. That was one of my first class I taught at Stanford. I didn't change it because 2021 gave us every single quadrant. We got the pandemic, we got hurricanes, you got terrorist attack in Afghanistan. We got it all. So that's something we need to be ready for. It's no longer business as usual. So how do we prepare for that? We're going to see that data is going to help. But don't think it's that, the reason why it's going to help, wait a little bit. The other thing also, and actually that was interesting listening to this whole point of subscription model for auto finance. We see models going away like super fast. And you probably, some of us remember this. Some of us weren't born, but I was at least. Yeah, 1 billion customers, Nokia, and where are they now? It's like a PSG in a Euro Cup, right? Where are they? Oops, did I say that? But yeah, 1 billion. And what happened is that, and that's actually something that, for me, these are slides I added when I listened to the talk this morning, is when you look at the business model, and that's what Nokia did. They were fighting for phones, and they say either we do better quality or we do cheaper, or better quality or cheaper. And you know what happened? That happened. And Jobs came in and said, you know what, I don't care. So we're going to do better and cheaper or whatever. I mean, we just break the rules. And that model has been going on over and over again. Car rentals. Oh yeah, we should do better or cheaper or better or cheaper. Well, somebody came and said, bam, we're going to change the way we consume cars. And last doors, you know, I'm going to go through hoteling. Same thing, the fight between Motorsick and Hyatt, while these guys were hitting each other, somebody came in and said, bam. And no need to remind you the market cap of Uber or Airbnb compared to the other guys. So maybe the time when you think about subscription is maybe not, because there were comparisons about this, maybe not thinking about should it be the new lease or different lease or long-term rental. I'm not a pro in that field, but the way these guys did it is like they just reshuffled all the cards. What has it got to do with data? We're going to see that data is going to be an enabler for many reasons, but the first I wanted to highlight is the following. To get to that level of disruption, it's not about data. It's actually about being innovative, agile, creative, collaborative, all this good stuff. The things that everybody knows already. The problem is, we know this stuff. It's obvious we need to do all this to survive. The problem is, how do we get to that? And this cannot be invented. This cannot be dictated. It has to be fostered, and this is where data comes into play. And it's funny because you pretty much use the same words earlier for consumers. They want value and they want time. Well, data is going to give you exactly these two things. Data is going to give you that visibility, that insight on your business, and mastering data is going to give you that free time so that you can stop and think and say, what's the next big thing? If you spend day in, day out in your Excel spreadsheets or punching numbers left and right, you're not going to get that time, and surely you won't get that insight. That is why, to survive digital Darwinism, we need to master data. And not only happy fews at the top of the company, but pretty much the whole chain of the company. So now, just to put things in perspective, is data the key to success? I mentioned several times that it was important, but I just want to reposition things. This is a very simple diagram that shows actually an analytic cycle. And I just want to remind you that what is the most important thing today is not the AI you run or the machine learning you run, is what is at the top here. Execution, action. You can do all the fanciest machine learning model on your car rentals, car subscription model. At some point, if there's nobody to push the car to the customer, it won't work. And that's what you need to focus on. Quality of service, quality of relationship with your client. But because time cannot be extended, as you maximize that time with your client or thinking about the service, etc., you have to get that time from somewhere else. And usually our business is always, actually alternating between two things. We got a challenge to solve, that's the question, and we need to find an answer. And then once we find an answer, we got a new challenge to solve and an answer, and a new challenge to solve and an answer. The faster we go from one end to another, the better. It means we have more time to actually execute and think and execute and think. So bottom line, data is the last thing you should care about to some extent, because that lower part, which is the analysis, which connects a question to a decision, should be the smallest amount of your time. This could be given to machines, automated as much as you can, because your real value is up there. So let's not be too over-focused with data. I have the chance to work with some of the best engineers in machine learning, well, I would say on the planet pretty much. And they are the first one to tell you that the real value in data, it's all of you. You who are going to come with the right question, the right challenge, the right idea of disruption. And then it's going to be you again, because at the end, you are facing the client. You are the one tweaking trying to tweak the offer so that the client works. The machine can help you, but you are still making that call. As a matter of fact, I tweeted a photo of the panel this morning I was in, and a colleague at Berkeley immediately said, Gauthier, it's only males on stage. I said, no, you're missing the lady, she's on Zoom. But that's why also I skipped that slide quickly, but it's important. That's why it's very critical that in our companies and our organization, we maintain, or we enforce, or we push, or we drive a level of diversity, because when it comes to inspiration about asking questions, debiasing the question we ask, and then debiasing the way we're going to act upon this question, I'm sorry guys, I'm part of the team here, but it cannot be a handful of guys making these calls. Not that we would do it worse or better than women, but there's too much bias. And that's something we need to be careful about. Because we are biasing the machine. The machine is not biased by itself. All right, so this was setting the stage. And now I want to take you to how machine learning works. Is that something you'd love to know? Like in 20 minutes, and you'll know how machine learning works. Interested? Or you already know?
No, we don't.
Yeah? Okay. All right. So let's go back in track. First of all, why did we need all this AI and machine learning? Same thing. You know, we like 10 years ago, oh, big data is everything, data lake, big data. I mean, where's big data today? I mean, did you hear about big data? I mean, please don't say big data at the dinner. I mean, you could be ridiculed, you know. So we don't talk about big data anymore. Is it the same for AI and ML? I think there's a slight difference. Big data is just big data. AI and ML actually has a real purpose, something that fits what we saw earlier. That's why I don't like buzzwords, but these ones, okay, there's a connection with reality. So when we look at what happened before, volume, great, but that's not something that we need to go after. Velocity in transactional system, yes, it's important, but when it comes to decision making, you just need to decide at the pace that your company goes. But the third V of big data, that's the one actually that triggered the revolution for AI and ML, artificial intelligence and machine learning, is like you were saying earlier, to understand a situation, we need to have access or to collect a vast diversity of data. And here's the deal. When you start collecting a lot of data, what was a very simple model 10 years ago, oh yeah, I got my lease program, I got the car model, the client, the age, etc. All of a sudden becomes a mess. You have data from a different system, the marketing, the call center, the website, from outside system, demographic, economics, etc., etc. And here's the issue. I don't know about you, ladies and gentlemen, but here my brains gets fried. My eyes, my brains just can't cope with it anymore. And that's why AI and machine learning came into play. That's what Ginny Rometty refers to as, actually augmented intelligence. Rometty from IBM, she said AI for me, it's not like artificial. It's augmented intelligence because we, human beings, still own the alpha and the omega, the question and the action, but our brain just cannot comprehend all this. So the only reason why machine learning is so fantastic is that it's going to boost us, like Steve Austin, the $300 million or $50 million man, whatever the conversion rate was. But at some point, you need to see that signal in the noise. You need to predict, to see patterns, predictable patterns that your eyes just can't figure out. And that's exactly what machine learning is going to give to us. So machine learning has been around for decades. But before that, we didn't have the data. Very, very little data was digitized. We didn't have the technology. Firepower, storage, was expensive. Today, we have everything. So it just, it was the perfect storm. So now, 15 minutes to tell you all the secrets about machine learning. So we're still far away from the Friday night dinner where you'll be able to shine with all these terms. So try to take notes and remember. So, it's still Tuesday. You might forget a few things. So in machine learning, as simple as it seems, there's only 3 things you can really do. 3. By the way, can I black this? Is there something I can black with this? I'm going to press. No, that doesn't work. Okay. There's no black. Oh, thank you. Thank you. So, yeah, so machine learning actually is very efficient to do things very narrowly. There is a tendency to think that AI is the Terminator and we're all going to die and that's going to be terrible. This is far from, from happening. We're very far from there yet. My favorite example is ask a robot to empty a dishwasher and wait. We're far away from just getting a robot to do these tasks. Now, ask a robot to predict which customer is going to leave you, how much a customer is going to spend. That's narrow AI. That the machine can do way better than we do. So I'm going to walk you through the 3 things machines do perfectly well, and that you could get like in the next 2-3 months easily from the data that already exists. Fabulous. So the 3 algorithms are like these 3 little creatures. They have names. The first group is called regressions. The second, classification. And the third, clustering. They kind of look cool, but they're very simple. Regression, that's the one we probably all studied when we were in high school or university. You're familiar with regression. And it's okay if you're not, but right, that evokes something. What is there to remember is regression helps you predict a value. So typically you say, oh, I'd love to see the value of this car. I'd love to see the value of this house. What you do is you're going to inject a series of features of the car or of the house or whatever good into the algorithm, and the algorithm is going to spit out a number, a value. That's how it works. Now, for this one, I'm going to tell you how machine learning actually works in that case. All the algorithms do the same. What they do is they learn from the reality, from what happened. There's no crystal ball. An algorithm to be smart or to learn needs to read tons of data that you already got with the outcome you already observed. And what happens is the machine says, oh, you fill me up with a house pricing, and I know the size of the house, the size of the lot, the type of the house, the area where it is. You give me all this, you give me the price, and I'm going to figure out a logic which connects all these features to that price. So next time you come to me with a brand new house with different features, I will have a rule in my head. And what I love is that replaces the approach we could have had at some point, and all of us on Excel probably tried this. If the house, or let's say a car, if the car is this old and it is this brand and or etc., a succession of ifs and then, which could be endless, machine learning doesn't need that. Machine learning is going to take a bunch of features and learn. Now, whether it's any good, you can give it a price, and let me show you what type of thing you get. Here, that's an algorithm that was trained about customer spending. How much customers are going to be spending depending on 5 features: age, marital status, region. There was professional status or something. And below is what was observed. And in Y is what the machine predicted. 1,000 lines enabled us to predict pretty accurately. You can see we have a diagonal, which means what you predicted is pretty much in line with the actual price. And another regression algorithm, which is even better here in that case, so these are funky names you can impress your friends with, XGBoost. Well, look at that line. Look at that line here. It took roughly to train this algorithm on 1,000 lines, and you have a lot more lines actually you could benefit from. It takes just like 10-15 seconds, and that's the level of results you get. So, take a few seconds to think about what are the values you'd love to predict in your daily business. Think about the values you already know, the system already has, and say, well, let's use ML to get all these values, look at the features that corresponded to these values to build a model, to train a model. And next time, instead of using like this, you'll have a baseline to work from. And that's it. So that's regression. Another one that is actually really cool to use, it's called classification. Classification, you don't predict a number, you predict a class. Very classic case here we teach to all the students that begin is the Titanic. Who's going to die, who's going to survive? And think about the features you get in the Titanic and think, make a parallel with your clients. What do you think the features are that are relevant to decide survival or not on the Titanic? Age, absolutely, that's one. This I couldn't train the model with. I didn't know. I believe nobody could swim by that time. Very few people know how to swim. The cabin. Wealth, wealth, cabin, exactly, the fair price. Age, cabin, and sex. Age, cabin, the fair price they paid, the sex, and also the number of kids, that's 5 features. 5 features you can predict on the Titanic who's going to die or survive with a precision of how much, in your opinion? 5 out of 10, 9 out of 10, 8 out of 10, 9 out of 10? With no effort, you can predict who's going to die or survive in 92% of the cases. 92. 5 features. Now go back to your client list, product list, and try to see which customers are going to churn, which customers are going to renew, which customers are going to purchase. You have thousands and thousands of operations you could rely on. You have tens of features. You're this far away from saying, you know what? Even if it doesn't pan out, I can try and see if there's a signal that can predict churn, repurchase, click, you name it. I actually had a small example here. Think about your alpha, your miles, your transactional system. Think about the type of data set you could get from your client or your product. There's roughly maybe 15 columns here. And somebody did a job, which client churned or not. That's the last column. This is known, you coded it. And then you say, hey, machine, please. Or you don't have to say please, but just be respectful, to. Hey, machine, please, from this, I think the data set I used, there was like 1,300 clients. Tell me if they're going to churn or not. 20 seconds later, that's what I got. I could predict that in 5,000 cases plus 1,600 cases that either they were not churning or they were. I was just wrong on 250 cases. It's not perfect, I agree. But come on. Instead of spending my marketing on pretty much 7,000 people, I'm going to spend it on maybe 96 or 200. Actually, are they going to churn? And I said, no, yeah, I'm going to focus on these ones. Yes, they're going to churn, and they're going to indeed churn. So I kind of divide my marketing spend by a lot. So that's classification. And I voluntarily showed you a data set to show you that the data underneath that is not complex. Last but not least is clustering. I know cluster has a bad vibe these days. Hopefully there won't be any more clusters. But that's the last type of algorithm we use in machine learning. Actually, this one is cool because we call it unsupervised, because it learns by itself. And the goal of clustering is to say, well, I got thousands of clients or thousands of contracts, and I just cannot market to everyone individually. That doesn't work. So I need to group them. The problem is I group them by what? I can sort them by age, but there's sex. Okay, by sex, but where there is what they do. But wait, where they live. I mean, all of a sudden you end up sorting up and down, and you can't really say what makes groups of clients homogeneous or not. Well, that's what the machine's going to do by running clustering algorithm. And what it's going to do is going to say, actually, let's make it this way. You're going to say, I want 5 groups in my clients or my products or my transactions. The machine is going to throw five dots on the chart, and then it's going to measure the distance of all your clients compared to where the dot landed. And how does it calculate the distance? Let's say if you launch a dart on salaries 100, it's going to try to get all the customers which salary is close to 100. And the second dart is like where it's 50, so it's going to get all the customers that are close to 50. And by iteration, at some point, it will iterate and slowly group the dots among centered on centroids, and you're going to have homogeneous groups. So that's how it works. And the beauty with clustering is that all of a sudden, what could be a mess here, you say, oh my gosh, these are all my transactions. Well, it's going to give you a color, it's going to give you a type. And all of a sudden you realize, like, yeah, I got these guys, these contracts right there in the lower part. Then I got the big violet here, some blues here, and wait, some pink there. And in 2Ds, of course, they kind of overlap a lot. But in multiple dimensions, you see them very clearly. What's the point? Well, once again, instead of having 20,000 different marketing campaigns, you have 3. And they're targeted towards people that are homogeneously grouped. I got better representation. Let's group transactions. This is like financial transactions from credit cards, but that could be as well payments and limits and leases, duration, whatever. You take a data set that is this big. Think about how easy it would be to extract from your transactional system that data set. So it's like ABCD all the way to O, so that's probably 19, 18 columns. All these features. And then I say, hey, go cluster this. Bam! These are all homogeneous groups that are here represented by balance and level of purchase. But you name the dimension you want to see them by. And here's another representation where it's, well, purchasing and balance, but I added a few more dimensions. But if you're not compelled, here's the 3D representation of the same cluster. And now you start looking at your transactions, your client, your product differently. And now you can come and see your marketing people, your sales people, and say, who's in charge of the orange? Who's in charge of the yellow or the purple? And you're going to find out that usually when you do this clustering, they match a reality of people. Maybe the wealthy on top, the not so wealthy at the bottom. But their customers you can handle with a lot more focus. And that, ladies and gentlemen, that's clustering. By the way, you mentioned Netflix. You know Netflix? We love Netflix, right? Yeah, have you Squid Game? Shall we do a gigantic Squid Game? Not. By the way, it's cool, but yeah, watch it with viewer discretion is advised. But Netflix, you believe that Netflix loves you. Netflix knows you. Well, actually, it doesn't really. The problem with Netflix is there's not enough data. You don't give enough data to Netflix for you to understand who you really are. Even if you binge, that's not enough. No, not even you. So to make enough of a group, they do clusters of roughly 20,000 people. And when they have 20,000 people that are the same, age, gender, grouping, region, blah, 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 then they have a data set that is compelling enough to start doing some profiling on what you might like, what you watch, etc. So they do use clustering for these reasons. But at the end of the day, they still feed you what they want you to watch. Don't be fooled. So there you go. See? Regression, classification, clustering. As leaders, that's all you need to know. Now there is that seed. It's not going to do magic, but it's going to give you a sense of direction. This morning, if you were in the session right there with the professor from Babson College, Julia, thank you, Politnik. Yeah. She mentioned that you could do analytics on churn, you could do analytics on the spending, you could do analytics on different choices clients would do. Push it one more level now. All this that can be done in analytics can also be predicted. Okay, a few minutes to close. I'll be right on time. A few things you need to remember. And that's why, I mean, maybe it's not your area of expertise, but there is a drawback. One of the hardest parts in data science is not what I just showed you. That is actually easy. Honestly, that is easy. The hardest part is to get the data. The hardest part is to ask the right business question. The hardest part is to make sure that when you start looking into a problem, you're not biased. You're not forcing the machine to think like you. So 80% of the work is going to be working with your data. The good news is, if you have a solid transactional system, chances are your data is not that bad because it supported transactions, so it had to be right. And that could be a great starting point. All right. I'll skip advanced visualizations. There's some cool stuff I'll be happy to show you. I would love to leave it to this message, though. I recently read a book about, taming the monster, taming the algorithm. The problem is algorithms are no monsters. They don't need to be tamed. Algorithm is just a few lines of code that can really do great things or very bad. You know who's going to be the bad element in that chain? Well, you're sitting in front of it, the human being. There's so many places where we can make algorithms go wrong. So as you embrace these amazing opportunities, because they're really cool, you're going to save a lot of time, gain tremendous insight. That's fantastic. You need that to innovate. Just remember that by the data we select, by the question we ask, by what we want to hear from the algorithms, we are the main cause for abuses, unethical approaches, and heavy biases in analytics. So now you know, be responsible, and good luck. And thank you once again, Team Will, with who I'm working on this topic.